Let's go ahead and get started. Any questions over? Uh-oh. What's going on here? No? Anyone remember what we were doing last time? What were we doing? Good. We were multiplying polynomials. And specifically, we were looking at this little table I had made in class. I said what we're going to do is we're going to look at these different possibilities: multiplying a monomial and a monomial, monomial and binomial, monomial, trinomial, binomial, 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 trinomial, 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 right? And we said monomial was one term, binomial 2, trinomial 3. And what we had gotten to is we had done monomial, monomial, like this, which meant we just dropped the parentheses and then just multiplied and collected and used properties of exponents. And then I had given you one example of a monomial and a binomial, which meant that we had to take the monomial and distribute it through the parentheses. And then each one of those became a monomial times a monomial, and then we went ahead and simplified. So what I'll start today with is a monomial, trinomial, and then I'll go to binomial, binomial, and I'll just continue through these, all right? So let's take a look now at a monomial times a trinomial now. Try and stay somewhat consistent with what the book's giving you. There we go. So how about this? How about if we have like 4x times negative 3x squared minus 5x plus 2. So if we have this, all we're going to do is distribute again, right? We have a monomial on the outside. We distribute it through. This time we have 3 multiplications that we have to do. Everyone okay with the fact that this is a trinomial inside, 3 terms? Okay, so let's do this. I'm going to take, first of all, 4x. I'm going to multiply it times negative 3x squared. Now, what's important is to realize that that's multiplication, not subtraction of that negative 3. Right? So if you need to, if it makes you feel better or more comfortable, put that in parentheses, as long as you don't go and try and subtract it. And then the other multiplication, I'm going to take my 4x, so I'm going to put a plus here, 4x, and I'm going to multiply it times the next one, which is what? Negative 5x. Again, notice that that's multiplication of a negative, so I put it in parentheses. And then finally, I say plus 4x times what? 2, positive 2. So I can just put 2 instead of a plus 2. And now let's do each one of these. How about that first one? We can rearrange everything, right? So I can do the 4 times the negative 3, which gives me negative 12. And then I have x times x squared, which is x to the 3rd power, x cubed, because we add the exponents. The next one, minus 20, right? Because 4 times negative 5 is negative 20. Then x to what? squared, right? And then finally, plus 8x. And that is it. That's what we're looking for. Can we collect any of those together? Why not? They're not like terms, right? Like terms, we said you had to have the same exact variables raised to the same exact powers. So at this point, you'd want to stop. You wouldn't want to try and put that all together somehow. Okay, so monomial, trinomial works pretty much the way that the monomial and binomial did, right? The distribution over the parentheses. All right, let's try the next type of problem, which would be a binomial and a binomial. Why am I not doing a binomial and a monomial? Because we already did that, right? But we said monomial, binomial instead of binomial, monomial. So binomial 2 terms times binomial 2 terms. So let's take a look at what would happen in this case. We'll start with a pretty basic one. X minus 5 times x plus 3. So I've separated my binomials with parentheses, right? The multiplication is implied, meaning I don't write a multiplication symbol, but the fact that there's nothing in between the parentheses means that there's multiplication there. So how do we multiply binomials and binomials? There's different ways of teaching this, all right? Depending on what you're comfortable with, all right? You'll like one way over the other. I'm going to show the way that I normally show it first, and then I'll show you a couple other ways. So the first way I show it is you start with this first term in the first binomial, x, right? You take that x and you distribute it through the other parentheses, almost acting like it's a monomial, okay? The x by itself is like a monomial. It's going to distribute through. Figure out what that is. Then after you've done the x, move to the next number, which is what? -5, right? And you will distribute that. I'm going to put the distribution on the bottom, but it's the same thing as on the top, right? Just multiply that through. So you do the x, multiply through the other parentheses, then you do the -5, multiply through the other parentheses, and you're done. That kind of makes sense? Okay, so let's do it. What's the x multiplied through the first parentheses here? So x times x gives us x squared. Then what's x times a positive 3? A positive 3x, right? And now I have done the x, right? The x has passed through the other parentheses. So I move to the next number, or the next term in my binomial, which is -5. I take -5, I multiply it through to x. What's -5 times x? -5 times x, right? You can't do anything to that. And then what's -5 times positive 3? -15. Are we done? No, why not? Those middle terms are like terms. I have a 3x and a -5x. Those have the same variable to the same power. So these two here can come together. And how do we do like terms? What do we focus on? The number, just the number out front. So what's positive 3 take away 5? Is -2, right? But -2x, we have to keep the term, the variable, I should say. -2x minus 15. Can we do anything to that? No. I'm going to start to point something out to you that, you know, this class is going to end here pretty soon. We only really have like 1 or 2 more little topics. Well, they're not little, but topics. And they're all connected to this polynomial stuff. In the next class, you're going to, in 320, if you take 320, the first thing you do is what's called factoring. And what factoring is you see in this problem how I started here and I wound up at the end? Ooh, I wound up here. That's called multiplication. Going the opposite direction, starting down here and going back up to this, is called factoring, and it's much more challenging to go the opposite direction. And that's what you spend the first few weeks of 320 doing. All right? Okay, that's one way to do it. That's the way that I recommend it. I mean, just as you'll see, you'll see why I recommend it here in a second. Let me show you another option. X minus 5 times x plus 3. It's something called FOIL. Have you all ever seen that before? FOIL. FOIL is an acronym. It stands for something. It tells you an order in which to do these. So the F stands for first. The O stands for out. Oops. Outer. Then inner. And then last. How many of you have seen FOIL before? Y'all like it? No? You don't like it? Okay. So let's see. FOIL's telling you that what you're going to do is you're going to multiply the first terms in each binomial together first. So you're going to do the first one here and the first one here, right? Multiply those. Isn't that just doing this right here? Yes? Okay, then you're supposed to do the outer terms. The outer terms are the ones on the outsides. So what I mean by that is this is on the outside and this one's on the outside. Do you see that? The blue, they're on the outsides. I do the outers and multiply those. So that means multiply this times this, right? And then I'm supposed to do the inner ones. Well, where are the inner ones? The -5 and the x are on the inside. Do you see that? Well, that's the same as doing the -5 times that, right? And then you're supposed to do the last ones. The last ones are the -5 and the +3. But that's the same as just doing that. So isn't FOIL exactly what I just did? Right? You started with x, you went to the 2, and then you did the -5 and you went to the 2, and it's the exact same result. Y'all see that? Okay. So I'm not going to go through the work because it would be exactly the same. The FOIL is just a cute way of remembering it. Now here's the last option. X minus 5 times x plus 3. This last option is a visual option. What you do is you take the x minus 5 and you write out each term vertically. I have an x and I have a -5. And then you write the other polynomial, the x plus 3, and you put it here, x and 3. And if you want, you can put a plus, but I'm just going to put, it's a +3. And what you do is you create a table out of this. How many of you have seen something like this before? Yeah? Do you like this one? No? Okay, and then what you do is you just, to figure out what's here, you say, all right, that's an x and an x multiplied together, right? What's x times x? X squared, so I put that here. To figure out what's here, I say, all right, that's an x and a what? -5. What's x times -5? -5x. All right, to figure out what's here, I have a 3 and I have a what? X, and that's going to give me a 3x. And then the last one here, I have a 3 and I have a -5. 3 times -5 is -15. And when you put all those together, you have the x squared, right? Which is, I'm coming back up to the first one I did, that's that x squared. You have this 3x, that's the 3x up here. You have -5x, -5x. Then you have -15, -15. And then, so you just write them all out and then collect your like terms and be done. Make sense? I don't care which one you use, but I would advise you to try and do the one that I started with, all right? To just kind of get the idea of FOIL out of your head a little bit. You'll see why in a minute, all right? Let's do another one of these binomials. I'll make it a little more challenging. How about 1/3 whoa, 1/3 x squared minus 4 times 2/5 x minus x cubed. Okay, is that a binomial and a binomial? Yes, 1, 2 terms here, 1, 2 terms here, multiplication between them, I have binomial, binomial. So the way that I am going to do this is I'm going to start with the first term in the first binomial, and I'm going to distribute that to the other 2 terms, right? What is 1/3 times 2/5? So I'm going to do this mentally, all right? What's 1/3 times 2/5? How do you multiply fractions? Straight across, right? So what's 1 times 2? 2. 3 times 5? 15. So we have 2 over 15. And then, what about the x's? X squared and x is x cubed. Okay, so that's my first multiplication right there. Now do the next one. The 1/3 is going to multiply times what? -1, right? That negative is like a -1. So what's 1/3 times -1? Well, it's -1/3, isn't it? What's x squared times x cubed? X to the 5th. Am I pushing too hard here to not show this monomial? I'm okay? What do I do next? Distribute the -4, right? The -4 is now going to distribute through like this. So what is -4 times 2/5? What's -4 times 2/5? Well, that's the same as -4 over 1 times 2/5, right? So it's -8/5. So I have -8/5, and how about variables? X. And finally, -4 times -1. That's my last term, right? I'm doing -4 times -1, which gives me +4, and then how many x's? X to the 3rd. Any questions? Are we done? No. Why? I have 2 like terms here, don't I? They both have x cubed. So how do we add like terms together? Add the numbers in front. So I need to take 2/15, and I need to add to it 4. Well, how do you add 2 numbers like this? Common denominator. So I'm going to rewrite 2 over 15 plus 4 over 1. So I need to turn this 1 down here into a what? 15, which means I need to multiply the top and bottom by 15. So 15 on top, 15 on bottom. That gives me 2 over 15 plus 60 over 15, right? And now that they have the same denominator, you just add across the top. 2 plus 60 is 62 divided by 15. So I'm ready for my final answer. I have 62 over 15 x cubed minus 1/3 x to the 5th minus 8/5 x. Is that all right? Fractions, right? Just got to pay attention, be careful with those. Okay, so I've done 2 binomials. Now I need to show you a binomial trinomial. And we're going to try and keep this one no fractions, all right? Okay, what if I had 4 y minus 3. That's a binomial. And then I had negative 2y cubed minus 10y squared plus 7y. Okay. If you're a big fan of FOIL, right? FOIL, we just looked at. If you're a big fan of FOIL, it's not going to work here, right? FOIL does not work. FOIL only works on binomial. That's why I'm not a big fan of FOIL, because if you only know FOIL, then you get this, and then you're kind of stuck. So what was the method that I showed you that I preferred when we had binomial instead of FOIL? What did we do? Okay, so we started with the first one in the first term, right? The 4y, and what did we do with it? We distributed it to everything in the other parentheses. Now this time, how many things are in the other parentheses? 3 of them. So I'm going to go to all 3 instead of just 2. So it's the same method that we just learned, right? Except I'm going from 1 to 3 instead of 1 to 2. After I do that, I'll do what? After I'm done distributing those through, do the same thing on the negative 3. And we'll go ahead and pass that one through to all 3 also. And then I'll look at everything I have, and I'll try and collect them together. So there's going to be a total of what? 1, 2, 3, 4, 5, 6 total multiplications that I have to do here. So let me try the first multiplication. What is 4y times negative 2y cubed? Negative 8, y to the what? 4th. Right? Negative 8 comes from 4 times negative 2. Y to the 4th is y times y cubed. Now I'm ready to move to the next one. What's 4y times negative 10y squared? So what's the number? Negative 40, and then y to the 3rd. I've done 2 of the 6. Now 4y times positive 7y. 4 times 7? Positive 28. Y times y? Y squared. Okay, halfway there. Now I do negative 3 times negative 2, which is positive 6. And how many y's will I have? Y cubed, right? Then I do negative 3 times negative 10, which is positive 30. How many y's do we have there? Y squared. It's weird because a lot of times I'll say, how many y's do we have? I know it's y squared, but we'll say 2 y's. 2y and y squared aren't the same thing. So technically, if you say 2y, it's not the same as y squared, but I understand what you're saying, right? We say, how many y's are there? Well, y squared. 2 factors of y. Okay, how many have we done? 1, 2, 3, 4, 5. One more. Negative 3 times 7 is negative 21. And how many y's? Just 1 this time, right? Okay, now what I do is I look at all this, try and collect any like terms. Looks like I have a negative 40y cubed here, and then over here I have a plus 6y cubed. And then with my squareds, I've got a 28y squared and I have a 30y squared. Negative 8y to the 4th has nothing to, no like term, so I just leave it. How many y cubes? Negative 34y cubed, right? That's negative 40 adding 6. Negative 40 add 6, get negative 34y cubed. Then I do 28 plus 30, 58y squared. And then I didn't have any y's by themselves except for this one, negative 21. So I am done. You see how approaching this way is much more useful than the FOIL would be? as my last example will again illustrate. All right? Here we go. Anyone still need this? Do what? No, I'm going to do try now. Try times try. Anybody have a guess as to how many multiplications we're going to have? Here's a trinomial. That's a trinomial, right? Here's another one. It's two trinomials, isn't it? We're going to have how many? 9. So where do I start? Distribute the x squared. The x squared will go through, right? It's going to start to look like a spaghetti factory here, right? Distribute that through. Then I move on to the negative 3x. I distribute that through to all three terms. And then I have to move on to the positive 2 and distribute that through. Got the idea? Okay, 9 terms. I better write small. Okay, first thing I do is x squared times 4x squared. What's that? 4x to the 4th. Okay, x squared times negative x cubed. So it's negative because we're doing like a positive 1 times a negative 1. So negative x to the 5th, and you get 5 by adding the exponents, right? What's x squared times 3? 3x squared. So I have now passed the x squared all the way through the other one. Now I move on to negative 3x and pass it through. What's negative 3x times 4x squared? Negative 12x to the 3rd, good. Now what's negative 3x times negative x cubed? Negative times negative? Positive. Positive 3, x to what power? 4, okay. Then negative 3x times positive 3. Negative 9x, right? Because I did have an x on that first, on the 3x, negative 3x. Okay, I've done 6 of the 9 multiplications. Now I need to pass a 2 through the entire set of parentheses. Okay, 2 times 4x squared is 8x squared. 2 times negative x cubed is negative 2x cubed. And finally, 2 times 3 is 6. There's all 9 of my terms. And now I need to collect like terms. So since you're writing in pencil, and you usually don't have colors, here's what I recommend you do to try and find your like terms. Okay, what I do is I look, okay, how many x to the 4th do I have? I'll just draw like a real light box around my x to the 4ths. And then how many x to the 5ths do I have? Well, I just have that one, right? X squareds, I have 2 of them. So maybe I'll use a circle on these. Okay, I'm going to circle my x squareds. X cubes. Okay, you want to do triangle? I'll do like a triangle around this and then a triangle around this. I'm just trying to visually see where things are so that I don't miss them. And how about just x's? I just have 1 of them, right? And then just numbers, I just have 1. So let's start with the boxes. 4x to the 4th and 3x to the 4th added together is what? 7x to the 4th. Now what I recommend you do now is cross them out, because you've done them. Now let's go write the negative x to the 5th. I was just about to mention that. I will when I get to the end of this. Okay, so I've got my x to the 5th, so I'm going to cancel it. 3x squared, I should have another one over here. 8x squared, 3x squared, and 8x squared is 11x squared, cancel them out. Okay, I have a negative 12x cubed. Over here I have a negative 2x cubed. Put those together. Negative 14x cubed. All right, I've already taken care of this one. Negative 9x, that's the only one I have. Done with it. 6 plus 6, done with it. Okay, now this, if you boxed it, it would be correct. What we like to do whenever we have a variable, a single variable in the problem, like here, the only variable we have is x, right? If we have x's and y's and z's mixed up together, we don't think about what I'm about to tell you. But if it's just x's, then we put in what's called descending order, which means the highest power of x down as you write it from left to right. So I'm going to write the highest power of x first, which was my negative x to the 5th. The next power I have is the x to the 4th, so plus 7x to the 4th. The next power I have is x cubed, so minus 14x cubed. The next power I have is x squared, so plus 11x squared. The next power I have is x. The next thing I have is no x, so the 6. This is what we call descending order. And I would just get used to seeing it or writing your answer in descending order. If it's one variable. Well, if it was all x's, you could combine them together, right? Like terms? Yes. I don't know if that answers your question. But. Well, they're both right. It's what is the standard notation that you see. And then when you get to college algebra or to the next class, what you'll do is, remember I said in the next class you're trying to go backwards, okay? So what you do, the first step is you look at the problem and you say put it in descending order. Okay, so that's the first step. So we may as well get used to that now. Put it in descending order so that we're used to seeing it in descending order. But technically it's not the wrong answer. It's kind of like if I say 4, well, that's the same as saying 3 plus 1, right? I mean, they're both 4. It's just what's the preferred way to write 4? 4, like that, right? Now, if they have different variables, then you don't worry about it so much because which one do you go off of, right? Because what if the x's have high powers and the y's are in their mix? So it becomes difficult to actually put them in a correct order. There is really not an order, so we don't worry about it. But in the next classes, really everything you deal with is going to be pretty much one variable throughout the whole thing. So you will be able to put a descending order on it. Yes. If there's several variables, don't even worry about it. Just box your answer. Okay, do you see now why I think FOIL's great, but not that great? You know, because this right here allows you to do some pretty crazy multiplications. This is called, we said it's multiplication, but whenever you have to do all that distribution over and over and over like we just did in the previous problem, we call that expansion or expanding the polynomials out. We don't call it foiling anymore. So that's the technical word for it. You don't need to write this down, but just think about this for a second. X cubed plus x squared plus x plus 1 times x to the 4th minus x cubed plus 2x squared plus 7x minus 1. Okay, those are polynomials, right? Now, we don't have a word for these anymore, right? Because it's 4 terms. Like, we don't call it a quadnomial. Over here, we have 1, 2, 3, 4, 5 terms. What's 5? Pent? We don't, remember I said after 3, we just kind of stop. We have 4 terms and we have 5 terms. Could we multiply these together? Yes. You would go x cubed, pass it through all of these, right? Then x squared, pass it through all these. X, pass it through all these. 1, pass it through all these. How many multiplications would you have? 20. It's however many terms you have here, 4, times however many terms you have here, 5. 4 times 5 is 20. So there's a connection between how many terms are there and how many multiplications you'll have to do. So this would be 20 multiplications, and then collect like terms and get your answer. All right, well, we do need to see, this isn't going to be crazy or anything. It's just a notation we need to be careful with. What if I said 3x minus 2? That's a binomial, right? But I put out here squared. We talked about this before. What does squaring something mean? Multiply it times itself, right? This means this. And then you would have to do what we just did. This is a binomial, right? So you'd either have to use your FOIL or you use what I was showing you, right? How many multiplications would we have if we did this? 4 of them, right? What is it that you have to be careful with? What is not correct up here? What's the mistake I see people make? Yep. Squaring each one and being done. Like square 3x. Oh, okay, that's 9x squared. Square negative 2. What's negative 2 times negative 2? Positive 4. And people say that's the answer. That's incorrect. When are you allowed to put a power through a parentheses like that? Only if that's multiplication inside. Only if that's multiplication. If it's addition or subtraction, that power cannot go through like this and become this. So that's the mistake I don't want you to make. But this, you just multiply this out. This would be 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. Negative 2 times 3x is negative 6x again. Negative 2 and negative 2 is positive 4. So there are your 4 terms that you would get from multiplication. You collect your middle terms together because they're like terms. It's in descending order, right? And we're done. Questions? Let me show you. If you had this right here, 3x, it's going to be hard. If I had 3x times negative 2 squared, see the difference between those two? Because that's multiplication, not subtraction. Then what you could do is you could take the 3x and you could square it, and you could take the negative 2 and you could square it. And it would be multiplication between. The property is this. X times y to the n is x to the n times y to the n. If you look back at, remember we had all those properties? I wonder how long it would take me to find it. No. So it's not day 18, not day 19. That must have been a review day. 17 properties. There it is. It was property 4. If there's multiplication between two things in parentheses, the power can go through. And then I showed you at the end of this class, there it is right there. Remember that? I was trying to show you why when you take something and square it, right? X plus y, if there's a plus between, that you do not square each one. This is a mistake. And then I showed you with a visual. I actually showed you by trying to convince you the area of this thing. Am I the only one that remembers that? But so that's what I was referring to. We had seen that before. So just be careful that you don't pass this 2 through to both. Just write them next to each other and then FOIL. Now watch this. I'm going to do a different example right below this. This is going to be tricky. How about 3x minus 2 cubed? Well, what does that mean? Multiply it times itself 3 times, right? And I'll get a lot of students that are like very comfortable with what we've done up to this point, and then they give them that, and they're like, what do I do? Well, watch. Here's what I recommend you do. Look at the second two right here, right? Could you just multiply those out? Just those two. And you would get exactly what we just got above, wouldn't you? You'd get that 9x squared minus 12x plus 4. So you'd have to do that, and this would become 9x squared minus 12x plus 4. And then what's still sitting in front of this? 3x minus 2. Now, isn't that a binomial and a trinomial? So now just pass the 3x through everything, and after you do that, pass the negative 2 through everything. So you would take your 3x here, pass it through, then you would take your negative 2, pass it through. You would have 6 multiplications. So cubing it, right, cubing that, you would first do the squaring part on just 2 of them, figure out what that is, and then come through with that last one. I'm not going to work it out, but do you understand? Okay, let's see. What would 3x minus 2 to the 4th be? Well, that means 3x minus 2, right? Times 3x minus 2 times 3x minus 2. Another one? 3x minus 2. It's torture. Any ideas on what to do? Yeah, okay, so you're seeing you could do like these two together, you know what those are, right? Yeah. And then you could do these two together, you know what those are? So that first one is 9x squared minus 12x plus 4. These other two together is 9x squared minus 12x plus 4. And that's a try and a try, which we could do, right? That would be 9 multiplications we'd have to do, but we could do it. With me? These are ugly, but I mean, just, it's the concept. The idea is there, at least. Okay, let me give you an assignment off this section. Page 389. Yeah, this is homework. Take a look at 19, 25, 27, 31, 41 is a little interesting. 44. 47. That looks pretty good. I'm gonna keep you away from fractions, and then take a look at 67. And last one will be 71. All right. Y'all okay? It's last day of the week. Hang in there. Well, last day of the week for us, right? Got a little more to go here. Okay, I'm going to take you on a little journey, okay? You ready? What is x plus y to the 0 power? Does anyone remember what anything to the 0 power is? It's 1, right? I'm going to move this over because it's not coming up on the screen. Okay, what's x plus y to the 1st power? What's anything raised to the 1? Itself, right? So watch oh, I forgot to put the answer on the first one. You said the answer there was 1? Okay, I'm going to write that 1 over here in the middle. Just bear with me for a second. And then you said the x plus y, the answer was x plus y? Okay, I'm just going to put the answer over here in the middle like this, x plus y. All right, what would x plus y squared be? Well, you'd have to do x plus y times x plus y, right? I'm not going to do it. Well, I'll do it real quick on the next page. X plus y times x plus y. I would have to do my expansion, right? This, 4 multiplications, and I'd figure it all out, right? Collect like terms, put them together. If you did that, you would get x squared plus 2xy plus y squared. Okay? Trust me, that's what would happen. If you do now x plus y cubed, you would have to do x plus y times x plus y times x plus y. Then you could like kind of do what I said a second ago, put 2 of them together and then come through with the other one and multiply, collect all like terms and stuff. You do that, you get x cubed plus 3x squared y. You know what, let me space that out a little more. 3x squared y plus 3xy squared plus y cubed. That's what you would get if you multiplied those together. Then, what if I said to the 4th power? Well, you could do 2 of them together and then multiply, and it would be 2 trinomials, and it would be 9 multiplications, and you do all that, and you get x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. Okay? I'll go one more, all right? If I do x plus y to the 5th and do all the multiplication, it will be x to the 5th plus 5x to the 4th y plus 10x to the 3rd y squared plus 10x squared y cubed plus 5xy to the 4th plus y to the 5th. So am I really that big of a math dork that I know the expansion of x plus y to the 5th power, that I've got that memorized? Do you think I'm that big of a dork or not? There's something happening here. There's a pattern. Does anybody see the pattern? Oh. Let me, okay, the power what? Power what on what goes up? Okay, the powers are going up as we go down the, okay, that is a pattern. There are a lot of patterns in this. But look at each row. Do you see a pattern in each row? When I say row, I mean each row. Is there a pattern in there? And focus on the variables. Look at the x's. In each row, look at the x's as you move from left to right. Okay, the powers on x's go down as you move from across the left, don't they? What happens? So let me see if I can express what I'm saying. Look at on this very first one. We'll forget the one for now. What's the power on that x? 1. Okay, is there an x over here? No, so the x is gone, which means the power is gone from a 1 to a nothing, right? Look at the power on x here. What is it? 2, and then in the next term, what's the power on x? 1, and then what's the power on x here? Nothing. What's the power on x here? 3, then 2, then 1, then nothing, right? Next row, x to the 4th, x cubed, x squared, x, and then nothing. Last one, x to the 5th, x to the 4th, x to the 3rd, x squared, x, and then gone, right? What's the pattern on the y's? They go up. It's opposite. It's the opposite of what's happening to the x's. Look at on the first, well, the second row. Here, there's no y, right? And all of a sudden, boop, I have y to the 1st power. Here, I have no y's, and then I have y to the 1st power, then I have y squared. Here, I have no y's, there's a y squared, there's a y cubed. Here's no y, here's a y squared, here's a y cubed, here's a y to the 4th. No y, here's a y squared, y cubed, y to the 4th, y to the 5th. So the x's and y's have opposite patterns here, don't they? X's go down, y's come up. The only thing that's really, truly still a question is how in the hell am I coming up with the numbers, right? 2, where did this 3 and this 3 come from, and this 4 and this 6 and this 4, and the 5 and the 10 and the 10 and the 5, right? Where did those come from? Well, there's also numbers on the outside. Do you see the numbers here? Here's a 1. Don't I have ones here? Ones here. Ones on the ends. Ones on the ends. Do y'all see those ones? Yes? The Chinese figured out the pattern of this thousands of years ago. All right? And what they discovered is that if you look at those numbers, it follows this pattern. Now this right here in mathematics is known as Pascal's triangle. It's named after a mathematician whose last name was Pascal. So the Chinese discovered it, Pascal used it later, and I don't know, for some reason, the way history is written, Pascal got it, the Chinese didn't get any credit for it. But the Chinese have it documented a long time before Pascal had it. So here's the pattern. There is a way to determine the next row of this. Can anyone see what the next row is going to be? Okay, one's on the ends, right? Can we do that? Where do you think this number comes from? It's 6, right? Are you getting that because you're coming down here and seeing 1, 2, 3, 4, 5? Is that the way you're getting 6? Wait, what? X plus Y? Oh, you saw a pattern that this number here was always that number? Is that what you're saying? Yes, that is true. That is a pattern. So I agree that will be a 6. But it's actually going to come, the Chinese discovered that it comes from the previous row. Here's what it is. Let me show it to you, and then you'll be convinced that it is true. If I take the previous two numbers above it and add them together, I get 6, right? The previous two numbers above it, I get what? 15. Previous two numbers above it, 20. Previous two numbers above it, 15. And then previous two numbers above it, 6. Let's just check. Is that the pattern? Look at any number in here. How about 4? Where does that come from? Previous 2, right? How about this 6? From the previous 2. How about that 10? Previous 2. How about this 10? Previous 2. How about that 5? Previous 2. You see that? So you could keep constructing this triangle. What would the next row look like? 1's on the outside, then what? 7, 21, 35, 35, 21, 7, and then 1, right? Go with me? So watch this. Where were we? Where did we stop? Back on Pascal's triangle, right here. I stopped at x plus y to the 5th. X plus y to the 6th would be, well, I know the first number is a 1, right? And I also know that the x power starts out where? What happens to the powers on x? They go down, right, as I move from left to right? So I should have an x to the 6th here. Okay, and how many y's do I have there? None of them, right? No y's. Then I say plus. Now, how do I get the number? Need to get rid of some of this highlighting here. So it would be this number and this number. So it should be a 6x to the, what's going to happen to the power in x? Comes down to 5. And now what about my y's? It comes up, so I should have a y. Okay, plus what's the next one? What's the number? It's the 5 and it's the 10. So it's a 15. X to what power? 4, y to the 2. Plus, what's the next number? 10 and 20. I mean, 10 and 10, 20, right? 20, what's the power on x? Third, what's the power on y? 3 again, right? So the x's are coming down, the y's are coming up. Next number, 15, right? X squared y to the 4th, right? Next one, 6 x y to the 5th. Last one, it's just y to the 6th. X plus y to the 6th If you were to multiply 6 of those together, you would get that. Now, would you agree that each one of these, x plus y, those are all binomials, right? And what I'm doing is I'm multiplying them out, so I'm expanding them. This is what's known as binomial expansions. Okay, these are the binomial expansions. So if you ever want to impress your friends, start listing out the binomial expansions. They'll be like, oh my God, you know all that? Don't tell them you know the pattern, but you can. I'm kidding. You're never going to do that. But you know what I'm saying? This is the part of mathematics where what we try and do is we try and come up with generalizations, general formulas, so that we don't need to actually multiply that all out. It's too much work. All right. Sorry, I have to continue. I just wanted to share that little thing with you. All right, so we have done adding polynomials, right? Subtracting polynomials, multiplying polynomials, which leaves us finally with division, right? Division. And let's just start out with the easiest case scenario, which is a polynomial, any polynomial, divided by a monomial. This is the best it's ever going to get for you, okay? If you ever have a polynomial divided by a monomial, you should be happy, all right? Because if it's anything other than that, it's going to require a lot of work. Here's an example of a polynomial divided by a binomial or a monomial. How about 3x squared y minus 5xy cubed plus 7 over x squared y? Do you agree on the top as a polynomial? How many terms? 3. So it's actually a trinomial divided by a what? Monomial. Okay, polynomial divided by a monomial. If you ever had this, all you have to do is take each term of the top and divide it by the monomial. So you basically split this up into 3 separate fractions. Notice I put pluses between each one, and that negative, I just put it up on the 5. That was just my choice. You could have put this as a minus and made that a positive 5 right there. It's really up to you. Why am I allowed to do that? Yeah, it's because there's only one, but think about it backwards. When we add fractions, what do we have to have? When you put 2 fractions together, what do you have to have? Common denominator. And then once you have a common denominator, you just put all the tops together, don't you? So if I said add these together, you would just put this plus that, right, and put them on top of the common? And that would be what's up on to start with, wouldn't it? All we're doing is going backwards from that. We're ripping that back apart. That makes sense? Taking it backwards. Now, just look at each one of these. What can you tell me about these x's, that x squared and that x squared right there in the first one? They can't, or you subtract the powers, either one. But x squared on top of x squared should just go away and become a 1. What about the y over y? They cancel out as well, right? So all that leaves me with is a what there? 3, okay? Plus, now what can happen here? What's x over x squared? X over x squared, y'all remember? It's been too long. X over x squared is the same as x to the 1 minus 2. You're taking the power on top, 1, subtracting 2. What's x to the negative 1. Yeah, it's an x on the bottom, isn't it? So all that's happening there when I do the x over x squared is I'm going to be left with an x on the bottom. Yes? Okay, and then what about the y cubed over y? I'm going to get y squared on top. Okay, and what about that negative 5? Just stays up top. So I'm going to have a negative 5 on top. We said we'd have a y squared on top, and what was still on the bottom? An x. Okay, what about the last one here? Can you do anything to this? No. Okay, we are done. We are done. So all you're doing with this polynomial divided by monomial is splitting it up and then just using properties of exponents on each one. And your answer may look a little weird, but that's just the way it is. Questions? All right. We are not going to be able to get to the next part of this, so I'd just like for you to do these 3 problems. I'll count it as a quiz grade, but you can work together and use your notes. And I'm gonna collect it as a separate. So do it on separate paper. Okay, I want you to multiply. Okay, the first 2 are just multiplications. The last one is a division of a polynomial divided by a monomial. I'll